Welcome to Module 3 on subplots and layouts. So this is one of the most practically powerful module in the entire course. In data visualization module, we have first learned like how to draw a single chart, and then we have learned which chart to draw. And now you will learn like how to combine the multiple charts into one figure, say creating it side by side comparisons, dashboards, and complex multi-panel visualization. So this module answers for the question like how do you show a multiple related views of the data at the same time? And the answer is by using the subplot. And after this module, you'll be using them in almost every project that you build. So by the end, you'll be able to build figures with 2, 4, 6, or even 9 panels, control their sizes and spacing, and you can share the axis between the panels for the comparison. So let us get started. We write any code, let us understand like why subplots exist and when you actually need them. So imagine that you are showing a sales manager the revenue trend and the cost trend. So if these are in two separate figures, then the manager has to flip between them, mentally align with the time axis, and hope the scales are comparable. A subplot puts both of them on the screen at the same time. There is no flipping needed, and you can make out an immediate comparison. So here you can show the different aspects simultaneously. So the data set even might have got multiple stories. The raw data and its distribution and its residual after fitting a model or having a different views on the same data. So the three subplots in a single figure will tell the complete story on a single image. So here, look at the diagram on the right side here. It is a 2 cross 2 plus one dashboard layout. So this is a kind of figure that you'll be able to build up by the end of this module. plt.subplot is the function which is used to create the subplots. So it uses a 3-integer system that you have to memorize it. Like the plt.subplot function has got the row, which is indicated here. Say that it is one row, then column and the position. So say subplot of 1, 2, 1 means it has to create a single row with 2 columns, and this position will tell you like which panel to activate right now. So if it is 1, then it is index. If it is not 0, then anything it is that it means that it is index. So if it is 2, it means that it is index. Okay. So here this first function plt.subplot of 1, 2, 1 will create the subplot in the first row, first column, and you will have the plot number as plot 1. Okay. And here in the next time, so it will create in the first row, the second column, and your plot position is going to be plot number 2. So now let us look into the piece of code. Like every plt.plot function, or let it be plt.scatter function, it will draw the chart on that particular selected panel. So once we trace, like you can see here that once after the subplot is being created, you can now create the plot. So you can draw the rising line into the panel 1. So this is the first row. Okay, there is only one row and it has got 2 columns. Okay, so this is a 2 column and you have got a single row. And at the position of the first row and first column, you will have your plot 1. So you can look at the output like 2 separate panel. You have it side by side. The left panel has got the blue ascending line and the right panel has got the red descending line. So these points are being plotted based on the values here. Say like for 1, 4, you have the point here. Now 2, 5, and then next is 3, 6. So you have got an blue ascending line here, and for these data points like 1, 6, you have got it here, then 2, 5, and then 3, 4. So this is how the output looks like. You can have multiple plots on a single panel. In this slide, we have seen like what is the use of plt.subplot function. Now there is a difference. We have got an extra which is ending up with yes, right? So extra character s. So here this s at the end is making out a lot of difference. So the key difference between the plt.plot function and the subplot of is that the plotter function is stateful. It selects out only the current axis one at a time. But whereas this subplots function, this will return all the object up front that you work out with the named variables. Now let us trace through the code. Like you've got fig, which is a variable, comma axis 1, comma axis 2, is I'm calling out the subplots function, subplots of 1, comma 2, comma, and figure size I've given as 10, comma 4. So now this will create, so this one line does 4 things simultaneously. So what does it does is that first it creates a figure objects, right? So this figure object is created and it is stored in the variable called fig. And then it creates a row with single row, that is 1 comma 2 means that it is creating a single row and 2 column grid. Okay, so a single row and a 2 column is grid is created at the second step. And third step is that it create both the axis objects. So here we have got the axis object, axis 1 and axis 2. So you can unpack them directly into axis 1 as the left and axis 2 as the right. And figure 10 comma 4, it means that it is 10 inches wide and your figure is going to be 4 inches tall. Okay. And now let us just call the plot function. So axis 1 dot plot of 1 comma 2 comma 3 and 4. So it is making out a pair of 1 comma 4. So you find here 1 comma 4, then 2 comma 5, and then 3 comma 6. And you can give out the title for this axis 1 as left and the axis 2 as the right. Okay, and you can see here like axis 2 dot scatter, we have made a scatter plot of 1 comma 6, then 2 comma 5 and 3 comma 4. And then you can call out the function called as type underscore layout of, so which is very crucial. Like without this, the titles and labels, they often overlap. So you can use this function type underscore layout of, which can automatically adjust the spacing so that everything can fit out very cleanly. And here the output shows that the left panel has got a blue line which is going up, and the right panel has got a red scatter dots which is going down. See like how to make out the vertical layout stacking the panel on top of each other. So this is perfect for a time series data where you want to share the x-axis, the time to visually align. So the key line is a figure axis 1 comma axis 2 is plt.subplots of. So what is this 2 comma 1 mean is it will make out 2 rows and 1 column. So you can see here it has got, we have got first row, second row and only 1 column, and we have given figure size as 8 comma 6. So 2 rows and 1 column. So this stack the 2 panels vertically, and figure size of 8 comma 6 where it is 8 inches wide and 6 inches which is tall. So for the vertical layout, it makes the figure taller than the wider one. So let us now look into the code. Like this axis 1 comma axis 2 unpacking is like when you have a 1 column layout, the plt.subplots of will return the one dimensional array of axes, and the Python tuple unpacking assigns them in order in the order from the top to the bottom. And here the code plots the sine curve, so which is in dark blue on the top, and the cos x curve which is in red pig on the bottom. So notice that both are sharing out. So here in the code you can see that it is sine of x and cos of x. So both the sin x and cos x is sharing out the same x range, which is ranging from 0 to 10. So which makes the comparison easy, like you can look straight down from any x value and compare the sine versus the cos at any point. And plt.tight underscore layout, as I have mentioned earlier, it is called at the end to prevent the bottom of axis 1 from colliding with the title of the axis 2. So you can look at the output here, like sine wave is on the top and the cos wave is the below. So both has been filled with the transparent wash of their respective color, like fill. We have written like fill underscore between with alpha value of 0.15. So you can just make out this a layout, vertical layout, and use it wherever that you require for the real world scenario. So you can use this if you have to make out for the real world example, say temperature versus rainfall over a period of 12 months. So like both, it can share the month as the x-axis and vertical like 2,1 layout, where you can see like when it rains and does the temperature drops. So you can read it vertically. Let me introduce to you the 2D grid. So the most commonly used subplot layout in the data science is this 2D grid. So in 2D grid, a 2 cross 2 grid, which gives you 4 panels. So as if we have the matrix, so this first plot is a position 0 row and 0 column. And the next scatter plot 0 row, first column. Now, first row and zeroth column, and the first row and the first column. So you can have 4 panels for showing out 4 different views of your data simultaneously with the help of the 2D grid. So the main key line here is figure comma axis is equal to plot.subplots of 2 comma 2. So 2 comma 2 mean here it is 2 rows, 2 columns. So the index will start from 0, then 1. So 0, 0, 0, 1, 1, 0 and 1. So we have got 2 rows, 2 columns, and the figure size is 8 comma 6. So unlike in 1D case, like where we unpack directly into axis 1 and axis 2, so here instead of this, the 2D grid returns the axis as a 2D numpy array. So you can access the individual panel by using the array indexing. So you can have like axis of a row number, comma the column number. So the indexing rule is this is all 0 base. So unlike the plt.subplot of method, so here you have got axis 0, 0, which is going to indicate the top left, axis 0, 1, the top right, the axis 1, 0, which is going to be the bottom left, and axis 1, 1, which is going to be the bottom right. So this code places a different chart, like different chart type in each and every panel. So you can see here like axis 0, 0, which is creating out a line plot. So by default, it is plot of method, it is line plot. So for 1, 4, so 1, 4, you have the point here. Next 2, 5, so you have got the point here 2, 5, and next is 3, 6. So this is the line plot. And now the next axis 0, 1, I'm making out the scatter plot. So scatter plot is 1, 4, then 2, 5, and 3, 6. And next, let us move on to the bar chart. So bar chart for A, it is going to be 3. So for A, it is 3. Then for B, it is 7. And for C, it is 5. So you have made the bar chart and the index of 1, 0. And for 1, 1, the histogram is created. So you have to count for the histogram. How many number of ones do you have here? It is only 1, right? So for 1, it is going to be 1. And then how many number of 2's do you have here? It is 2. So for 2, it is 2. And for 3, so 3 you have got 3 3's, right? So for 3, you have got 3 3's. Now for 4, you have got 2 4's. So 4, it is 2 4. And for 5, you have got only 1 5, and you have got the histogram. So as if we have learned earlier, this tight underscore layout will help you to make out the proper alignment across the entire panel. So for getting the comma and the axis like 0, comma 0. So if you forget this, this is a general common mistake that the learners make. So you have to make out very clear that the comma is being used rather than using axis of 0, comma 0. So you're not supposed to uh, indicate the index as 0 of 0, but instead you have to use this axis 0, comma 0. Now let us see about the figure size and the spacing. So figure size, as we know, the figure size has got two parameters, width and height in inches. So the actual pixel size is equal to the figure size into the DPI. So the common starting sizes is 10, 4 for a 1 cross 2 horizontal layout, wide and short, and the other common starting sizes would be 8, 6 or 10, 8 for a 2 cross 2 dashboard or 2 cross 2 grid. Now, roughly, it is going to look like a square, and for the dashboard, it is 12, 6, which would be very large and more room for details, and 12, 9 for a 3 cross 3 grid, which is 1 inch per panel in each direction. So what is mean by this DPI? Is DPI is the resolution. So the default, it is usually 100. For presentation of our slides, you can make out the DPI to be as 150, and for print of a publication you can make it to be as 300. So say that a figure when it is given as 10, 6 at the DPI of 150, then it would produce 1500 cross 900 pixel image. So this is how is an figure size going to have an impact on the pixel size also. Like now the try underscore layout, as I have told, like it is it will automatically prevent the label overlap. And then we have got something called as the subplots underscore adjust. So this is a manual fine tuning. So here it means it has got two parameters within the function. It is head space and W space. Head space means the horizontal space, and the set space is the height space. So the vertical gap between the rows as a fraction of the subplot height, and this W space is called as a width space, which is a horizontal gap between the columns. So for head space, it is between rows, whereas this width space is between the columns. So generally the values in the range from 0.3 to 0.5 are typically used for the different types of charts. So remember that you cannot use both the constrained layout is equal to true and the plt.title layout of on the same figure. So what is meant by constrained underscore layout is when it is being set to true, say, then this is very smarter than the tight underscore layout of function, and it handles the color bars, legends, and the complex layouts better. So it is mainly recommended for the complex dashboards. Grid specification is the most powerful and flexible way to create the subplot layout in the Matplotlib. So let us break out the uniform grid constraint and create a panel of different sizes. So say that we have a function plt dot the subplot of 2, 3. So it creates a perfect uniform 2 cross 3 grid where each panel is of same size, right? So, but what if you want to have a wide summary panel on the top spanning all the 3 column with 3 detailed panels below? So this is not going to be a uniform grid, right? So it can be done with the GridSpec. So you can make out a non-uniform layout with the help of the GridSpec. So now let us look at the code one by one. Like we have to import the pyplot library and pyplot plot. Once it is imported, you have to import the GridSpec. So this GridSpec, this lives in the GridSpec submodule. So we have to always import this GridSpec separate. And now you can give out the figure size. So figure size is plt.figure of figure size of 10 comma 3. You have to note here that you're not supposed to use here plt.subplot of, because this grid spec works only out with the plain figure and it does not work out with subplot of method. So this is the main thing that you have to remember whenever you use the grid spec. So then you can give like the grid spec of 2 comma 3 comma the figure is equal to fig. So what happens is it creates 2 rows, 3 columns, and the 3 column virtual grid is created. So now let us move on with the axis 1. So axis 1 is assigned as figure comma. You can add now the subplot of the grid of g of 0 comma colon 1. So what does it mean? It is slicing operation, right? So the slice g of 0 comma the colon means that row 0 and all the column. Okay, so it is only row 0 and all the column. Okay, so this is the syntax of GridSpec, which is so powerful, which has got the numpy slicing. So you can see here this entire row and the entire column. So this is row 0 and the entire column is taken into consideration as axis 1. So it will cover up this entire area. Okay, got it? And now axis 2 now I have given as fig dot add underscore subplot of g of 1 comma 0. So 1 comma 0 it is of row 1. So this is your row 1 and column 0, right? So row 1 and column 0 you are going to have this axis 2. Okay. And what about this axis 3? So fig dot add underscore subplot of 1 comma 1 colon. What does it mean? Like for the first row, so this is your first row, upper one is a 0th row, so this is your first row. So row 1 and now the column 1 and the 2, right? So you have got once after you have got this column 0, so we have made it as 1 comma 0 for axis 2 and the rest of the spaces, right? Okay, so that will be considered for what? The axis 3. So this panel spans the second column. And now the result is what that you have here as the output. So the top is a wide sine wave which is spanning the full width, that is axis 1, and the bottom left is the small bar chart which is of axis 2, and the bottom right you've got a wider scatter plot which is spanning out the 2 columns, that is axis 3. Say that for a use case I can make out an example like scientific papers which can often use this grid spec to have a large main figure with a smaller annotation figures beside and below it. So now we have seen like the each subplot is independent, right? So the different chart live happily together. So this is the power of the axis model. So once you have an AX object, then you can call any chart function on it. The 4 panels, they do not need to know about each other. So let us trace out like how to make out a mixed plot types in a single figure. Okay, fine. Now, let us have like axis 0, comma 0. So this all is very common, like figure, comma axis, plt.subplot of this. We have seen it earlier. So it will create 2 rows and 2 columns. And figure size is 10, comma 7. Okay. And now let us see like how to make out a mixed plot type in a single figure. So axis of 0, comma 0, like plotter function will always create the line plot. So line plot, it will make out the cumulative sum of the random values. It will create a line plot of the with the random number. So I've given the random number as 50. So it is going to give me a cumulative sum, the line plot for the figure title line of cumulative sum. Okay, so this is the line chart that I get. Now let us make out the scatter plot on the axis 0, comma 1. So scatter plot on the axis. So this has got noise versus the noise. So there are 2 independent normal distribution variable called as x and the other is going to be y. And this shows like what that no correlation is like. It can make out a normal, you can make out a normal transparency, the coral red, the alpha given as 0 0.6 like. So you can make out this scatter plot. And then we can make out the bar plot as we have seen earlier, like the simple categorical comparison like Q1, then it is going to be 120, and Q2 150, Q3 135, and Q4 as 180. And axis 1 comma 1, we are going to create a normal distribution histogram. So I've given like 500 samples from a normal distribution of 0 comma 1 with 30 bins. So we have got 30 bins, and the bell curve shape is very clearly visible here. And the plt.type layout, as we have mentioned earlier, so at the end it can prevent the 4 panels titles are being overlapped. So this is how the output will look like 4 completely different chart types which are together in a single figure, and each one is clearly titled, and each uses a different color from the module's consistent color palette. So this pattern is exactly like what we use for the explorative data analysis, like when you first get a data set and you wanted to quickly see like what does the time trend look like, is there any correlation, or what is the distribution. So these 4 panels, one command can be used to generate and save them. So next, let us move on to the method called as axs.flat. So this axs.flat, this is small, but extremely it is a powerful feature that you can use over here whenever you make out the chart. So this significantly, this will reduce the amount of code that you write when working out with the 2D grid subplot. So here you can, the problem without this axis dot flat is that you have to then iterate over the panel in a 2x2 grid, which is a native approach, right? So the solution is when you have the axis, when it is defined as a 2D numpy array of the axis object, then this axis dot flat is a special iterator that can yield all the elements in the row major order, that is from the left and to the right. So at any time that you are applying the same operation to all the panels in the grid, then you can use this axis dot flat. And now let us see about the method called fig.suptitle of. So this is the essential feature for any multi-panel figure. So this can set the single title above all the subplots. Say you can give like a quarterly performance 2023 for the end. Let there be n number of plots in this entire figure, and you can give the subtitle, which is something like a title for the entire panel. So there is a difference between the SUP title, subtitle, and the set title of method. So set title of method, it sets a title for the one subplot, that particular specific axis, right? But whereas this subtitle, SUP subtitle, it sets a title for the entire figure, okay, which can appear above all the subplots. So that is the beauty of this subtitle of method. And there is something called as the twin axis, which is one of the most visually powerful and the most easily misused feature in the matplotlib. So this slide will explain you like what it is and how it works and the critical rule for using it correctly. So let us see like, and what are the problems that this twin axis can solve is like sometimes like you want to compare two variables on the same chart, okay? So you have got here, for example, this is the month like Jan to August, and you have got two variable. One is volume and other is price. Okay. Similar to that, if you want to compare two variable on the same chart that has vastly different scales or unit. Okay. So see here, the volume has got the scale from 0 to 2500, whereas this price has got only from till 180, right? So 0 to 180. It has got a different varying range. So when you have such a sort, then on a single y-axis, the price line would be invisible because it is 10x smaller than the volume bar, right? So the solution is that you can use the twin x of method. So you can see here in the code, it is twin x of method, which can help you like to create a new axis that shares the x-axis with the ax1 but has its own independent y-axis on the right side. And when you plot your two different series, each in their own axis, say axis 1 dot plot of month comma price, okay, so price will be on the left y-axis, and axis 2 comma bar, okay, the volume on the right y-axis. So the color shading as coding is very really mandatory. Like this is the most critical rule here. Like when you have a two different y-axis, that you must code the color properly. Like the left y-axis label in the same color as its data series, like the blue for the prices. You can see here we have colored code as blue, and even for this you have made it as blue. And the right y-axis label in the same color as it is the data series, the red for volume. And without color coding, the readers cannot tell like which scale belongs to which series, right? So you have to be very careful whenever you use this twin x of method and to make out a proper color code. And you can see here like axis 1 dot the y label of, here you can see that axis 1 dot set y label of. So set y label of method, you can use it. The blue label will matches out with the blue line, you can make it out. And here the volume, you can make out the same color code. Set, you can set the y label. So look at the output, like the blue line for the price and for the red transparent bars for the volume with the combined legend like proper color coded axis label. So the caution here is that the twin axis can mislead if the scales are not labeled very clearly. So some data visualization experts want that using this twin x of method is not advisable. So when you have doubt, you are not supposed to use this. Rather, you can make out two separate subplots instead of this twin axis of. And now let us see, like this is a capstone slide of this entire module 3, like a complete production ready. I wanted you to create a 4-panel sales dashboard. So like here, the every line of code here uses a technique from the previous slides, which are combined into one realistic example. So this is what the data scientists actually deliver to the stakeholders. Like it is not just an individual chart that they make out, but they make out a cohesive multi-panel dashboards that can answer multiple business questions at once, right? So let us understand the data setup first, like the month. We have given the month starting from January and then through December. So 12 months of 2023, okay? So let it be from Jan to December, and the revenue is the monthly revenue values, which is going to be in thousands, and the regions is going to be north, south, east, and west. The sales by region, the number of units sold per region, and uh, the ad spend, okay, the ad spend which is paired, which can be paired with the resulting revenue lift. So this is what I wanted as a dashboard at the end of the program. So like we can now let us move into the code. Like you can see that figure comma axis is plt.subplots of, so subplots of will create out the a subplot of 2 rows and 2 column with a figure size of 12,7 and figure.subtitle. So subtitle, I told it was make out the entire the complete title for this entire charts is going to be sales dashboard for 2023. And you've got 4 panel, each answering for a different question. Like top left, you can see in axis 0, 0, like how did the revenue trend throughout the year. So this is a line plot with fill underscore between for the visual base, and it shows the revenue curve month by month with the data points marker, right? So the upward trend is immediately, it is very much visible. And in the top right, it is axis 0 comma 1. We have made a bar charts like which region sells the most. So bar chart with 4 color coded bars and value labels above each other, say like north and the east one, which leads other than the south and the west. And now you can see at the bottom left, axis 1 comma 0, like axis 1 comma 0, it is a histogram of 400 order sizes. Say the normal, the log normal shape is typically of a real order data, like many small order, few very large ones. So you can see the order sizes. And the bottom right, it is axis 1 comma 1. So does more ad spend actually drive for the revenue? So if the ad is spent, is the revenue getting increased? You can see the comparison here. So the scatter plot with a trend line, like each dot is one advertising campaign, and the positive slope confirms that if you spend for ad, it correlates with the revenue lift. So this is how you make out a dashboard for a real world scenario or a real world problem. So what do you notice from the output is that the four panels together, it answers the trend, geography, the distribution, and the correlation, right? So the four fundamental business question has been answered with the help of this dashboard. So the stakeholder who's seeing this dashboard can get a full 2023 picture in a single glance. So it is quite, the figures are very worthy than making out with a pen and a paper. So once you have built out now a multi-panel figure, now you need to export it, right? So you have to save it. So how do you save it? Is you can use fig.save fig of the file name. So let it be, I'm saving it with .png extension. So you can save this, and you can give the DPI. So I mentioned earlier how to use DPI. So DPI 200 will give you a very good resolution. So it is dots per inch. So more dots, sharper the image, and larger the file. So you can have like 150 to 200 as DPI for a good quality image. And if you wanted to make it for your publication, then you can go ahead with 300 to 600 DPI. So which is going to be very sharp. And the figure size, you can have it as 12 comma 7 with a DPI of 200, which can produce a very good pixel image of 2400 cross 1400. And there is different file format that you can save, like a PNG, which is a pixel based, or raster based, which is good for presentation, or you can save it as PDF, which is a vector, it is math based, or even you can save it as SVG, which is another vector format. It is good for web pages or for editable graphics. And you can make out the face color as white, that the background color can be given as white. And some Matplot themes generally uses a transparent background. So when saved as PNG with the transparency on the dark background slide, the chart text may become invisible. So you can set always the face color to be as white, which can ensure a white background regardless of the theme. And you have to always use like fig dot save figure of the method to save your figure. And these are some of the common mistakes that the learners make out using the subplot of method. So the first method is the overlapping title, so which can be overcome by the tight underscore layout of method. And second is the tick label truncation, which can be overcome by using the bbox underscore inches is equal to tight. So when you save, so this can help you to avoid the tick labels truncation, and the different scales mislead, like each subplot can rescale independently. So better you can use the sharex is equal to true and sharey is equal to true. So this can avoid this problem. And the code is one Jane function, like it is hard to maintain and reuse. So you can use functions whenever you have to deal with different panels. So now let us look into the hands-on and the exercise for you to create a weather dashboard. like you are not supposed to skip this building the weather dashboard yourself. Only then you'll be able to understand the concept and it becomes your permanent skill, right? So the task which I'm giving you is to create a 2x3 grid of subplot of figure size 12, 7, and you are going to create a grid with the panel 0, 0 is going to be a line plot, 0, 1 bar chart, 0, 2 histogram, 1, 0 you are going to make out a scatter plot, and 1, 1 the box plot, and a pie chart. So you can, when once after you complete this entire weather dashboard, you will be very clear with all the different charts types as well as the subplot concept. So I request all the learners to make out this summation. So this exercise uses all the 6 chart types. So it is an easy way of making you to exercise yourself, and the working solution will help you to have an assurance that you have learned the chart types as well as the subplots. So now let us have the recap. So congratulations on completing this module 3, like the subplots and the layouts. So let us recap everything, like what all that we have covered up is the 2 APIs, like you have got plt.subplot of and plt.subplots of, and when to use the plot of and when to use the subplots of method. And we have seen about the different layouts, like 1 cross n, m cross 1, or m cross n layout, so that you can make out a layout properly. And whenever you wanted to have a mixed size panels, you can use the GridSpec of method. And if you have to make out the shared axis, then you can use sharex is equal to true and share y is equal to true, which is going to give you all the scales as an identical scales. Then twin axis of method, as we have seen, the twin x of method will give you a dual scale chart, and it makes out the reader to be very readable. And spacing, we have seen the tight underscore layout of method, and the subplots underscore adjust of it can manually control. And we have seen like how to create a multi-panel business dashboards. And this is all about that we have covered out in this entire module 3. And what is going to be next is module 4, which can covers up the customizing the axis and the legend, the tick marks, how to make out the tick labels, the axis scales, the axis limits, the legend placement and style. So after module 4, your chart will look like truly professional, and it is not just correct. So thank you. Thanks for watching.